Hello friends and welcome to the Engineering Circuit Analysis Basic Course, lecture number 2. So today we will be discussing about the definition of charge and definition of current. So let's start with the definition of charge. So basically in nature, we know that just like matter, which is a fundamental quantity of nature, charge is also like a fundamental quantity of nature. So charge, there are two types of charges. One is the positive charge, and the other is the negative charge. Usually electrons are associated with the negative charge and protons are associated with the positive charge. Now this charge has a value. The charge of the electron is minus 1.6 in 10 power minus 19 coulomb. The C is called coulomb, which is the unit of charge. Therefore, the unit of charge is coulomb. So the charge of electron is equal to minus 1.6 into 10 power minus 19 coulomb. And the charge of the proton is nothing but plus 1.6 into 10 power minus 19 coulomb, because proton is associated with positive charge and electron is associated with a negative charge. The other property of charge is that the charge is quantized and charge is conserved. So what is the meaning of being quantized? We'll see what is the meaning of the charge being quantized. For example, let us take the electron charge to have a value of say E. So E is minus 1.6 in 10 power minus 19 coulomb. The other charge will be 2E. Some other charge will be 3E. There is no charge like some decimal 1.77E. The charge is always quantized E, 2E, 3E, 5E, etc. Okay. And the other property is that the charge is conserved. It means that the charge can neither be created nor destroyed. It can only be converted from one form to another. The charge cannot be created or destroyed, but only can be converted from one form to another. Now, you know that the unit of charge is coulomb. So what is the meaning of 1 coulomb? Okay. So what is the meaning of 1 coulomb? For example, you are having a wire. Okay, you are having a wire, and let us assume that there is 1 ampere current which is flowing through the wire. Of course, current definition will come as the next topic, but let us assume there is 1 ampere of current flowing through the wire. Now, if 1 ampere of current is flowing through the wire and it is passing through this point, every second you will measure 1 coulomb of charge is moving past that point. 1 coulomb is measured every second when 1 ampere of current passes through a wire at a particular point. So if this is that particular point A, and 1 ampere is passing through that point, if you try to measure the amount of charge which is moving, so in 1 second, 1 coulomb will move, 1 coulomb you will measure when 1 ampere of current is flowing through that point. So that is about charge. Another is the representation of charge. This is another important thing. Charges can be of two types. One is static charge, just like positive and negative charge. They can be either static charge or they can be instantaneous charge. Instantaneous charges. Okay. Now static charge, they don't depend upon the time. All the time they will have a single value, constant value. Whereas instantaneous charges, they are dependent on time. They may have different value at different point of time. Okay. So static charges are usually represented by capital Q or small q, whereas instantaneous charges are having the factor of time here. So they are usually represented as Q of t. They are represented as Q of t. So whenever there is a representation like Q of T1, T2, anything like that, it means that it is an instantaneous charge. Next is the definition of current. Okay. Basically, current is nothing but the flow of charge. Charge definition we have seen. Current is nothing but the flow of charge. Now, current has, for a proper definition of current, it should have a magnitude and it should have a direction. For charge, there is only magnitude. But for current, you are having both magnitude and direction. So what is the definition of current? Okay. The definition of current at a specific point and a specific time. So the current is always defined at a specific point. For example, you are having a wire here like this. The current is defined for a specific point and for a specific direction. It is the instantaneous rate at which net positive charges is moving past that point. Okay, so if you are having some net positive charge like this, okay, plus q, they are moving across this point. It is the instantaneous rate at which these net positive charges move across this point. Okay, so mathematically, current definition is the instantaneous rate of change of movement of instantaneous rate of change of positive charge. So it is also represented by I is equal to dq divided by dt. This will give the magnitude, and current also has a direction. In this case, the net positive charges are moving from left to right. So the current direction will be from left to right. Okay. So the direction of conventional current is the direction of the movement of positive charges. In this case, we are assuming positive charges are moving. So the direction of current, or it is specifically called conventional current, it is also from left to right. Okay. Now let us take a simple numerical so that if you can just revise all these concepts. Which of the following is a correct representation of current? That is the numerical. So you know that for the correct representation of current, you need a magnitude and direction. These two quantities are important. So in the first option, you can see that there is a magnitude. There is a magnitude that is there, but there is no direction. There is no direction. Therefore, this is not a correct representation of current. The second option, you can see there is no magnitude, but there is a direction. There is a direction. So this is also not a correct representation. The third case, you can see the magnitude is I of t, and there is a direction which is given. Let me call this 1 to 2. 1 and 2, these 2 points, let me call it 1 and 2. So the direction is from 1 to 2. So it has a direction also. The direction is also the same. So here the answer is C. C is the option which has a correct representation of current. Now in physics, you might have learned a simple concept like force. You see the force has a direction and a magnitude. For example, this is the direction. This is equivalent of representing the same force. If I just shift the direction like this, I change the direction, I can write it as minus 3 Newton. These both are equivalent. Similarly, in current also, for example, we are having 2 points, 1 to 2. So the direction is from 1 to 2 and the magnitude is 3 amperes. I can change the direction of current from 2 to 1 like this, and I can write it as minus 3 amperes. See, these both are equivalent. Okay. So this is a very important concept. So if it is from 1 to 2, 3 amperes, it is equivalent to 2 to 1, and let us put it minus 3 amperes. Okay. So these both are equivalent circuits. The other numerical, this is also very important. They are given that electrons are moving from left to right. Okay. So this is the left direction. This is the right direction. Electrons are moving from left to right, and the current created is 1 milliamperes. So you have to find what is the value of I1 and what is the value of I2. This is what you have to find. Now the current which is given here is conventional current. The current which is given here is conventional current. Okay. So electrons are moving from left to right. So electrons are moving like this. Okay. So in what direction will the positive charges move? The positive charges will be moving in the opposite direction, from right to left. And the direction in which the positive charges move is the direction of conventional current. This is the direction of conventional current. Okay. And that conventional current value is 1 milliampere. So any current which is given or any current which is measured is always conventional current. You have to understand that. So now you can see this diagram. You can see that I2 is in the same direction as the conventional current. I2 is the same, and everything is flowing through the same wire, right? So these all quantities should be, magnitude should be equal. So I2 is in the same direction as conventional current. So I2 will be equal to conventional current. That value is 1 milliampere. Okay. But whereas if you see I1 and I2 conventional current are in the opposite direction. Okay. And you remember this concept which I told you. See, this and this are equivalent. Okay. So with the same concept, you can see that I1 therefore it will be equal to minus I conventional, because they are in the opposite direction, and this will be minus 1 milliampere. So I2 will be equal to plus 1 milliampere. I1 will be equal to minus 1 milliampere. So we will conclude the video today. This electrical is easy signing off, and tomorrow we will in the next video, we will be going through some more numericals associated with charge. Thank you.